2.1 rectangular coordinates. And graphs. So obviously the big thing we have was the distance formula and midpoint formula for this section. And then we also had the stuff about if 3 points are collinear, like what that looks like. So to start with, they give us 2 points P and Q, and it wants us to find the distance between the 2 points and then the coordinates of the midpoint. So number 18, I've got the point P, which is -8, 4, and the point Q, which is 3, -5. And it doesn't matter as far as the formula goes which one we call like point 1 and which one's point 2, as long as we keep it the same for both of them. So the distance is the square root of so I'm going to say 3 and then minus a negative, so that's going to be +8 squared plus -5 minus 4. Let me square that as well. So this is equal to the square root of 11 squared plus, what's that, -9 squared. I'm just going to say 9 squared. What's 11 squared? 121. What's 9 squared? 81. So that's going to end up being the square root of 202. And I usually will just leave it like that as far as like the distance formula, even if that can be broken down, which I actually don't think it can. But if something can be broken down, sometimes I do, sometimes I don't. But as long as you like get to this, that's fine. Then the other thing they want us to find is the midpoint between the 2 points. And so that gives you an ordered pair when you're finding the midpoint. You add the two x terms together, divide them by 2, and then add the two y terms and divide them by 2. So this is going to be -8 plus 3 divided by 2, and then 4 plus a negative, so -5 over 2. So that's going to give us -5/2 and -1/2 for the midpoint. We're going to do more with the distance formula, but do y'all feel okay about that if I don't do any more just like this one? I don't mind doing it. We're going to spend a ton of time doing distance formula on this next problem. So, okay. So the next ones, it says determine whether the 3 points are the vertices of a right triangle. And so essentially we're going to find the distance between each of the sets of points to get the 3 side lengths of the triangle, and then we're going to plug them into the Pythagorean theorem and see if it makes sense for them to be a right triangle. So 26, the first point is -2, -8, nope, just kidding, -2, -5. The next point is 1, 7, and then 3, 15 is the other one. So you could plot these if you want a visual, but we don't need to do that, and those numbers are a little bit large, so that would be kind of annoying. So I'm going to call this point A, this point B, and this point C, and I'm really just doing that for a reference point as far as when I'm doing the distance between, so I can label like which ones I'm doing. So first I'm going to do the distance from A to B, then I'll do B to C, and then I will do A to C. So the distance between A and B is the square root of 1 minus a negative 2, so that's 1 plus 2 squared, plus 7 minus negative 5, so 7 plus 5 squared. So that's the square root of 9 plus 144, and that's going to be the square root of 153. So that's the first distance, or the first side length. Then the distance from B to C, got the square root of 3 minus 1 squared plus 15 minus 7 squared so that's going to be 2 squared is 4 plus 8 squared is 64, so that's going to be the square root of 68. Then I'm going to do the distance between A and C. And it doesn't matter if I do like C to A or A to C, it's going to end up being the same thing. So the square root of 3 minus negative, so plus 2 squared, plus 15 minus negative, so plus 5 squared. So that's going to be the square root of 25 plus 400, which is the square root of 425. So now I have these three distances. Other than the square root of 68, I don't really have any idea in the range of what these numbers are approximately equal to, so I'm going to plug them into the Pythagorean theorem, but fortunately everything in the Pythagorean theorem is squared, so that means that all of those signs will go away. So Pythagorean theorem is that a squared plus b squared equals c squared. The hypotenuse has to be the longest side, so based on that, which one is my hypotenuse? AC. So that's going to be the square root of 425 squared. The other ones, it doesn't matter. So 153 squared, or square root of 153 squared, and then plus the square root of 68 squared. So that ends up being the square root and the squares all cancel each other. So 153 plus 68 equals 425. Well, 153 and 68 is, what is this, 11... 221, I think, which is very clearly not equal to 425, so this is not a right triangle. If they come out equal, then it is a right triangle. So pretty easy. Determine whether the points are collinear. So collinear means, or it says, let's see, 3 points are collinear if the sum of the distances between two pairs of the points is equal to the distance between the remaining pair of points. So if I take the distance between like point 1 and point 2 and the distance between point 2 and point 3 and I add them up, that should be equal to the distance between like the whole thing. So let's look at number 32. -1, -3, -5, 12, 1, -11. So again, I'm going to give these names just to make it easier. as far as doing the distance. So, and basically, the setup of this problem starts out the exact same as the previous problem. At the end of it all, we're just determining if they're collinear or not. So, we have the distance from A to B, just the square root of -5 minus a negative, so +1 squared, plus 12 minus a negative, so +3 squared. So that's the square root of 16 plus 15 squared is 225. So then that's the square root of 241. Now, as far as determining if they're collinear or not, I'm not going to be like squaring the numbers like I did in the last one. So I actually want to find the exact value. So at this point, I would type in your calculator and figure out what that is. That's weird. So the square root of 241 is, and I would go say 2 decimal places on these. This is 15.52. And then the distance from B to C would be, let's see, 1 minus a negative, so +5 squared, plus -11 minus 12 squared. It's a big number. So then the square root of 36 plus 23 squared, which is 529. So this is going to ultimately be the square root of 565, which is approximately equal to 23.77. And then I need to do the last one, which is A to C. So that's going to be the square root of 1 minus -1, so 1 plus 1 squared, plus -11 minus negative plus 3 squared. So that is the square root of 4 plus 64, which is the square root of 68, which is approximately equal to 8.25. So the way we determine if they're collinear, it doesn't necessarily have to be that A to B and then B to C add up to be A to C. It doesn't necessarily have to be in that order. So what we do is we take the biggest one and we set the other two added together equal to the biggest one, and we see if that makes sense. So in this case, the biggest one is 23.77. And we say that's equal to, we add the others together, so 15.52 plus 8.25 and 15.52 plus 8.25 is equal to 23.77. So these are collinear. Did I spell that right? No, there's 2 L's. So basically, as far as this section goes, you're just finding, well, you're doing a lot of distance formula. There's a few midpoint formula. Determining if something's, or if the points that they give you make the vertices of a right triangle, and then determining if something is collinear. So, any questions about any of that? All right. Then I'm going to go ahead and give you problems. 15, 19, 23, 27, 29, and 33. So 2 of each kind.